Thank you. Good morning, everybody. It's a great pleasure to be here. We saw this morning some of what's happening with digital Earth at the global scale, and I want to share with you some things that are happening more at the urban scale, at the city scale, at the design scale. And that's some of the work we're doing, both at the Senseable City Lab, it's our lab at MIT, and in our design practice. So just to begin, just a few sentences about what our lab does. And, I'm Italian, and everybody in Italy grows up with a picture like this in their bedroom. But the reason I'm showing you this is that something interesting happened in Formula One over the past 10, 15 years. Now, 10, 15 years ago, if you wanted to win a Formula One race, you need a good car and a good driver. You need a good, solid physical stuff. Now, today, if you want to win a race, you also need something like this. Something like this is the system made of thousands and thousands of sensors onto the car, collecting information in real time, sending this information to all of those computers where it's analyzed, it's been processed, and decisions are made in real time. In other terms, that is what engineers would call a real-time control system. And the real-time control system is a system basically made of a sensing component and an actuating component. Sensing, collecting information, and actuating, responding to that information. And sensing and actuating is really what we do, what every dynamic system does, and what every living system does. When we meet each other, we sense each other, we shake hands, we touch each other, we smell each other, and then we respond to that. So that's really the basic of of most systems on the planet. Now, the amazing thing we believe today is that our cities, for the first time, are starting to behave like that Formula One racing car. Our cities have been covered, layered with many, many types of digital information, with networks. Think about the cell phone network, still quite recent, how much it transformed our cities and the way we live, with sensors. And because of that, yes, they're starting, the way we collect information, the way we respond to that information is really changing. Almost as if every atom out there of the physical world were becoming both a sensor and an actuator. Well, you might say all of this is good, but where is all of this leading us? And there was an exhibition a few months ago at MoMA, the Museum of Modern Art in New York. We were part of that exhibition. The title was Talk to Me. And we thought it was a good title that Paolo Antonelli gave to the show, because it's really about, thanks to this, it's almost as if our cities, our buildings, our environment is starting to talk back to us. The interaction between us and the physical environment is becoming much more dynamic. We talk to each other, we respond to each other. And if you want, it's nothing else than the old dream of Michelangelo. When Michelangelo sculpted the Moses, so the story go. He took a hammer, he threw the hammer at the Moses, there's still a little chip on the knee, and shouted, "Perché non parli? Why don't you speak?" And today, because of all of these digital technologies, actually our cities, our buildings, our objects are starting to speak back to us. Now, just one word about cities, why we believe cities are important. Well, 4 numbers. Cities are only 2% of the Earth's surface, but 50% of the population, 75% of energy consumption, and 80% of emissions. So if we can do something for cities and for running our cities more efficiently, then that can be a big deal. Now, having said that, I want to share with you some of the projects we've been involved with, and I separated them in 2 components: a sensing component, projects that deal more with sensing, and then the actuation, so how we can respond to all of this digital data that we can capture. And about this digital data, just one number. If you take all of the information, all of the data that was produced by humanity from the beginning till 2003, well, that number, if you measure it in terabytes, gigabytes, whatever, that number is the same amount of information that was produced over the past couple of days, between Saturday and Sunday, yesterday and today. So that gives you a staggering amount of digital information we can collect. A lot of this information is collected in cities and allows us really to get a different understanding of the environment we live in. One example, one project we've been working on now for a couple of years is called a trash truck. And our initial motivation was the following. If you take this computer the one here on the podium, you know everything about it. Every chip on this computer, you know where it was produced, how it moved on the planet, how it was assembled, how it became this machine, how it went to your desk. However, a few years from now, when you throw it away, you know very little about it. The global supply chain is very well known and understood, but what happens to things when we throw them away is much less understood. Sometimes this is what happens when we throw them away. So our idea is there anything we can do in order to better understand what's happening to our waste, to the things we throw away? And one idea was, imagine we develop a little chip that we can put on waste, and then we can follow waste and see where it goes. So we did a first deployment. It was the very initial one in Seattle. Yeah. Here you can see the first deployment, 500 people involved, 3,000 volunteers, 500 volunteers, 3,000 objects, every possible thing. And then we started following them. Here you can see the day of deployment. After a few days, you see the main landfills next to Seattle. But then a big surprise, how far some stuff was traveling. Sometimes in crazy way. Look at the trace that went to Chicago and then to Baja California. A lot of waste from Seattle coming to us in Boston. Going to Florida, especially, you know, cell phones, electronics, things that need special processing. We thought the Farewell Symphony was the music we needed. Well, what did we learn from this? Well, we did the project with two aims. The first one is, you know, well, once you have all this information, then you can actually start thinking about how the system could behave in a more efficient way. Now, think about, you know, as an engineer, you get all these traces, and you saw that a lot of stuff moved really not in an efficient way. Look at the trace I showed from going for thousands of miles east and then going west again and so on. So one thing is, you know, really when we have this information, we can start thinking about, can we optimize this kind of removal chain? And actually on this project, we've been working with Waste Management, one of the largest waste management companies in the world, really to try to learn this. The other component that we thought is very important is how people can change their behavior because of information. And that's really what affects us every day. Because of all this incredible amount of digital information, as we saw also in the previous presentation, then we can actually change our behavior. So we can know more about our environment and respond to that. And one of the most telling things was at the end of this project was somebody who told us, you know, I used to drink water in plastic bottles every day, and then put the bottles out of my door and, you know, think they would disappear. But now, after the project, I know they don't disappear. They actually just go a few miles from home and they stay there forever. And because of that, I actually stopped drinking water in plastic bottles. Now, then there's a third thing we learned from the project that actually was completely unexpected. But it happened more recently when a burglar came to our lab at MIT and stole a lot of stuff, including some of the tags that tell you where they go. And here is what happened. All right. Well, you know, this was an example of this kind of sensing, of how sensing today allows us really to collect information to an extent that we couldn't just a few years ago. I want to give a few other examples. One amount of sensing is what we call crowd sensing. It's about all the information we all collect every day and we post online, and how this information from Twitter feeds to Flickr data to Facebook and so on, how all of this can actually tell us something about our cities and our environment. That's one of the first projects. Actually, we were one of the first groups to look at Flickr data and actually how that can help us, for instance, to understand something about what's going on in cities. You know, Flickr is a database where people upload a lot of pictures, and if you look at the pictures, then you can learn something. This was one of the first things we did was with the city of Florence, and they were interested in tourists and see where do tourists go. So you can actually look at where tourists take pictures in Tuscany, in Italy, and then in Florence you can zoom in and look at the city, the most popular places, and even zoom at the level of the building. That's the Duomo, one of the main landmarks in the city, and where people go and what they like to look at. Now, the interesting thing is that if you actually add something more, and every picture has in the header has the timestamp, so it tells you at what time it has been taken. All of that is public information online. Then if you do that, you can actually do traces and see how people move. Now here I got a question for you. So here you can see Tuscany, and you got Italians and Americans moving and taking pictures in Tuscany. Now, where are the Americans? To the left or to the right? Who thinks to the left? Raise your hands. Okay, who thinks to the right? Okay, more or less half and half. Well, the winners are Americans on the left, to the left, and actually, you know, you can see that if you come from the United States, you go to Italy, maybe you go once in a lifetime or every 10 years, then you'll go to the main cities. Like you got Pisa, Florence, Siena, Perugia. Well, look at Italians who are, you know, in Tuscany, they go many times, they are in the country, and actually they will try to find little small places, hidden places, little gems. This island called Island of Elba, you know, no Americans, but a lot of Italians on the little island. So how, really, it tells you how people move on space in a different way. Well, we took this further in a project, then this was both some technical analysis and scientific analysis, but also an exhibition at the Design Museum in Barcelona. And what you see here, for instance, is something that our students expressed a lot of interest in, and was looking at all these pictures uploaded on on Flickr, to see where the parties are in Barcelona. So actually, so you see in real time what happens in the city, the pictures people take, and you see the best places. You identify all the pictures related to parties, and you can see the best places to go parties. Incidentally, they even managed to do a scientific paper on the correlation between Britons and party that turns out to be very, very high in the city of Barcelona. And then, you know, what you can do, you can actually take all these pictures, look at the color of the picture. Here we will try to address a very important problem in Spain, that's drought. During the summer, the country gets very, very dry. And actually, they have a number of sensors and monitoring stations scattered across the country to monitor drought. And we said, well, why don't we try to do it actually through all of our eyes? Actually, the name of the project, we called it Ojos del Mundo, the world's eyes, like borrowing the eyes of all the people over there to actually understand what's going on. And here you can see how the country changes in color, and kind of you can monitor drought through all of these pictures being taken, and how they go from very, very green during the winter months to something much drier during the summer. Well, you know, this is part of crowd sensing. Now, if you combine all of this together, and I'll go very quickly here, but you get something we're working on in Singapore, where we have a lab, which is, you know, imagine combining all of these data sources from sensors, from networks, from crowdsourced information, and making it public and accessible to people. So here you can see Singapore in real-time data from all the networks. So you see what's going on the telecommunication network, on the cell phone network, all aggregated data. Temperature and energy, so how much energy is consumed in the city, and how that correlates with the temperature increase. How the city changes during special events, that's Formula One in Singapore. Even simple things, when you have all this incredible amount of real-time information, can help the most unexpected things, like this is taxis and rain. And actually, it's very difficult to get a taxi when it rains in Singapore, but when you combine information and share it with people, you can get a better match between the two. How the city expands and shrinks during the day because of traffic, how the city becomes larger in terms of travel time. And then all of the global flows, that's all of the real-time information about all the things that are coming into Singapore, like containers or flights or going out from Singapore. All right, so all of this was about just a quick summary of sensing and how today we can sense and collect information about our cities, about our planet, to an unprecedented extent. But now, as in the case of the Formula One racing car, the goal is to win the race. The goal is actually actuation, is how we can use this information, process it, and make decisions on the top of it. Sometimes, and that's, here is what I'm showing you a few projects. Sometimes an easy way is just to share the information, and this can promote behavioral change. For instance, this is the main idea behind this project. That's a project with SNCF, the French railway company. And what we did, we started looking at CO2 emissions. And actually, here you can see the city of Paris. Here, if you look at travel time, how big is the city in terms of travel time with different modes of transportation, by bicycle, by metro, or by car. However, if you were to use a system based on CO2 emission, if you had a budget of a certain amount of CO2 emissions you could use, that's how you can go, which is exactly the opposite. That's how far you can go by bicycle, virtually anywhere in Paris, or by metro or by car. And the idea then we developed with them was, imagine we could actually quantify CO2 emissions in a very easy way. CO2 emissions, especially from transportation, which are 1/3 of global CO2 emissions. And how can we give people feedback about this just with no user input? Because today you can do it. There's many websites where you can go and say, today I've done that many miles by foot, by car, by plane, by horse, and they tell you the total CO2 emissions. But actually that, people will do it for a little bit and then usually get tired and stop doing it. So how could you do it automatically? Well, the interesting thing is that most of us, as we heard also in the previous presentation, now have a smartphone with sensors in our pockets. Most of us are like a walking GPS, a walking camera. I've got a microphone and so on. And actually, if you look at this, using this information, we can understand automatically the mode of transportation. And that was quite interesting to develop. This is, for instance, how your cell phone sees you from your pocket. So the accelerometer in your cell phone when you're on a bus sees you like this. When you're walking, it's like this. When you're biking, it's like this. On the metro, if you were horseback riding, you'll see trotting or galloping. You see all the frequencies of the activities you're doing. And then using that, you can actually get automatically CO2 emissions. And then, the idea is this will be an app soon so that people can, if they want, use it. And at the end of the day, with no effort at all, you get your CO2 being emitted, but you also get energy, calorie burnt, where you've been. So it becomes a way of having information about your daily patterns that perhaps can help you to promote behavioral change. In this spirit of more information then allow us to make different decisions and to change our behavior. Now, there's certainly a lot of things that can be done in this space, but I wanted to share with you a couple of projects that go more into the physical space, because architecture traditionally has been the way to really actuate and to actually change our environment, to do this to close the loop between sensing and actuating, to have this feedback that fully goes all the way around. And I want to share with you a couple of examples. This is a project we did with the mayor of Zaragoza. Zaragoza is the city in Spain that won the World Expo just before Shanghai. And the theme of the expo was water. And the mayor came to us with a very precise question. Water has been a beautiful ingredient of architecture and planning for hundreds and thousands of years. How can we use today water in a different way thanks to digital technologies? And one of the ideas came up at a workshop at MIT was, imagine you have a pipe, like you see here, and on this pipe you've got many, many solenoid valves, tabs opening and closing controlled by a computer. Then you can create like a water curtain, which is a water curtain where you can show images, pictures, patterns. You can make it interactive, so as you approach the curtain, it will open up to let you jump through. So that was the idea that we presented to the mayor. The mayor liked it, so we got the commission to design the pavilion at the entrance of the expo. There's a pavilion. It's all the walls are made of water, where you can write, you can show images or patterns. No doors or windows, but when you approach the pavilion, it opens up to let you in. Inside, also, all of the walls expand and shrink based on how many people you have. It becomes a kind of fluid, dynamic architecture. The roof is also covered with a thin layer of water. And then if there's too much wind, you can actually lower the roof to minimize splashing. Or at the end of the day, you can actually close the building and the whole architecture disappears, hopefully without anybody underneath. There are sensors as well for that. Well, here you can see the building before the opening. This guy was very puzzled. He stopped there for like 15 minutes looking at what was going on. Here you can see actually before adding on the physical water, on the pixels made of water, adding projections, so the digital and the physical combined together, digital projections on the top of water. Here it was myself, trying not to get wet, entering the building. And I should tell you now what happened actually one night when all of the sensors that detect when people approach and open up the building and the walls stopped working. You know, all of the sensors are connected to a computer, the computer crashed and, and they stopped working. And so actually all of us, we were all terrified because the building would do some crazy things. It would do cuts and holes and things, but it wouldn't respond to people anymore. But actually, that night turned out to be one of the most fun nights ever, with thousands and thousands of kids from all of the city, from all of Zaragoza, going to the building to play a different game. Not anymore a building that you approach it and it opens up to let you in, but a building where you need to play like this. And for us, that was an important thing because as architects, as engineers, we always think that we know how people will use the things we design, but then actually reality is always a surprise. In this case, it was a good surprise. Now, the same type of changes that we see at the architectural scale are also happening at the urban scale. And here I want to share with you an example from a new city we are developing. It's in the center of Guadalajara in Mexico. It was presented by the President Calderon at the World Economic Forum a few months ago in Davos. And the same type of changes of digital technology are actually affecting really the way of living in the city and the way of refurbishing or building new cities. Here are just a few slides.
That will transform the city into one of the world's leading centers of digital creation. The Ciudad Creativa Digital draws on the strengths of the site, its talent, historic fabric, and connections to achieve a new social and environmental sustainability. Its courtyards of unparalleled beauty, as in the Hospicio Cabañas, a UNESCO World Heritage Site, become the design theme of the new city, integrating living, working, and leisure in a human-scaled urban environment. While taller elements enable the density of a sustainable 21st century development, the park is the backdrop to Ciudad Creativa Digital, a place where social interaction and culture nurture talent, innovation, and creativity. The courtyards, new places of work, rest, and peace, immersed in Guadalajara's year-round pleasant climate, generate a unique outdoor working lifestyle, a new magnet for the world's creatives. The highly responsive urban fabric, effectively a living lab for digital technology platforms, fosters the growth of future media industries. Ciudad Creativa Digital, a unique investment opportunity to shape tomorrow's creative economy. An unparalleled development to serve Guadalajara, Mexico, Latin America, and the world.
And in this case, we've been exploring, we're still exploring with one of the aspects that we find very interesting about digital technology is that, in the end, really, all of this is not about technology. It's about us and how technology can help us live in a different way. In this case, for instance, imagine in a place where year-round you got, the climate in Guadalajara, they call it, it's always summer. It's sunny summer or, rainy, cloudy summer, but, always very, very pleasant. And the idea of how we can actually use technologies and the power we have today to be more flexible. We didn't have this power 5 years ago. 5 years ago, we were chained to a desk, chained to a computer. We couldn't move from that. And if we had to work, we had to be there 5 or 10 years ago. And today, how we can use this liberating power of technology in order to live in a city or to work in a different way. And in the end, in a better way. So it's not about technology, it's really about us and about how technology can allow us to do new things. And in this case, because we want to use the courtyards, the traditional courtyards of the city, like in this UNESCO World Heritage Site called Hospicio Cabañas. So, we also invited a number of leading digital designers from all over the world to imagine what a courtyard could be, a new type of working environment. And here you can see some of the crazy ones that came out. This is from Germany, quite fun, from Jürgens Meyer, how this could become a place of living and working together. This is kind of a digital cave by Meijin Jung in the United States, with all this digital information. This is the one we actually gave as a suggestion, filling the courtyards with pixels and becomes a transition between us and the outside world. Well, this is what I just give you a quick overview of the sensing, of some of the projects we've been working on, both on sensing and actuating at different scales. But we think that this also has other implications on the way we look at cities. Cities of yesterdays or projects of yesterdays dealt mostly with physical things, and we knew how to make them. If you think about a city used to be made of bricks and concrete and stone and mortar, and we knew how to deal with that. Now, cities of tomorrow will be made of concrete and silicon. And how to combine these things, we still don't know exactly how to do it, and how to have actually different departments in a city, the IT and the infrastructure come together and help and work together. So I wanted to share with you just one project in more detail that shows how we're trying to bridge this in an interdisciplinary way in our team at MIT. This project is a project we did with the city of Copenhagen. The mayor of Copenhagen has been a partner of our lab for many years, and she came to us with a very precise question. Again, how could all of these digital technologies help us with transportation and traffic in Copenhagen? Now, the incredible thing, if you go to Copenhagen, is that transportation looks like this. Copenhagen is a city that had a lot of cars in the city center a few decades ago, but it's a city where today you have a lot of bicycles. 30% to 50% of all trips every day are actually done by bicycle. So we started working with this, and we came up with the following idea.
Welcome to the Copenhagen Wheel, the wheel that turns your ordinary bike into a smart electric hybrid, quickly and easily with no additional batteries or wires. The Copenhagen Wheel allows you to capture the energy dissipated while braking and cycling, and save it for when you need a bit of a boost. Controlled through your smartphone, the Copenhagen Wheel becomes a natural extension of your everyday life. The Copenhagen Wheel is your personal trainer, sensing your effort level and providing you with real-time feedback about your fitness and exercise goals. The Copenhagen Wheel also enhances your experience of the city. It connects you with things a cyclist wants to know: upcoming traffic congestion, road conditions, and pollution levels. Choose to keep your data or share it with your friends and other cyclists through social networks like Facebook. As you ride, you also collect green miles. It's similar to a frequent flyer program, but good for the environment. Elegant, responsive, smart. A new mode of transport for a rapidly changing world. So turn on your life and turn on the city. The Copenhagen Wheel.
And so here, this was the initial idea, and I just want to share with you how the project came together, and how actually we had people from many different disciplines working together in order to make it happen. Again, this started at a workshop at MIT, where different ideas were developed for Copenhagen, and one of these ideas was this kind of funny wheel, that at the beginning was really not much more than a sketch. You can see it here, something you could get your energy when you brake, but there was nothing really technical inside at the beginning. A few sketches. But then, every time you got an idea, you don't know if it works or not, then, the best thing is, let's try it out. So then we did put together a small team and started to build it. You can see some initial components being prototyped. Today is very quick and easy to prototype with digital machines. This idea of Fab Lab, that you can actually very easily use 3D printers and so on in order to try out what you want to do. Combining the batteries, mounting everything together. Here the first one, looked okay, but it was working, and the mayor liked it. Here it's in Copenhagen, in the main square in Copenhagen. So she said, okay, let's go ahead. So, well, again, back to the drawing board, trying to understand how we could really define the brief better. We wanted something that could be easily retrofitted to any bicycle, could do regenerative braking, intelligent locking, so that the bikes will recognize you, will talk to you, will unlock just if it's you, will see it from your phone. If somebody else steals it, then will just charge your batteries, but cannot go very far. Electric motor to kick in when you need it, sensors, and also making the bike like your personal trainer when you're riding. So we had to do completely new redesign. Here it's in the lab, working on it, selecting the motor, putting everything together, different pieces. And then how to connect the center to the wheel, to the rim. This was the initial idea. Looked pretty bad, pretty terrible. This looked better, but actually didn't work out. Didn't work. You can understand it because the torque from the center is not easily transmitted to the rim. And then we had this idea of using these spokes that actually go from the rim, simply touch the hub, and then go back to the rim. And some people in the lab thought it would work, some people thought it wouldn't work. We thought this would look cool because it's a good way to connect it, but it's not connected to the hub, so it's only touching it and going back in tension. And so again, if you got a doubt, let's try it out. Again, a little model built with a laser cutter, a better one built with a 3D printer, just putting the spokes, combining all of them together. He was very skeptical, as you can see from his face. And then, mounted, it was working. So that became the way to do the spoking. And then we had to do all the control from the phone. So far, in what you've seen, we had mostly designers and mechanical engineers and some electric engineers. Here we had some programmers and some human-computer interaction designers coming together to do the interface, how this could be controlled by an iPhone, can be controlled by an iPhone. And then, all of the sensing. Now, believe it or not, but today people do a lot of sensing through bicycles. Putting sensor on bicycles to understand air quality and a number of other things. Actually, there's projects like this, but we thought this was not the way to go. So we decided to go for very small sensors to put inside the wheel, to measure CO exposure, noise, NOx, distant travel. If you see in this little video, you see just a few bicycles in Copenhagen, actually in a few hours, are able to cover most of the city. So, if you think about how we monitor air quality in cities today, you got monitoring stations just in a few places, and, that creates problem. You got very limited information. You can have issues like what happened in Madrid with the mayor of Madrid a few years ago. He was, saying that the air quality was getting better and better, till when the population found out that what he was doing was taking the measurement station and moving them more and more inside parks. And here you actually get the real exposure of people to air quality. And you see just a few bicycles, how they can cover the whole city. So, but anyway, from this, having done this, then we had to build the prototypes to present at the World Summit in Copenhagen. And here you can see different prototypes. You can see all the different parts coming together, being programmed, the microprocessors inside the wheel, mounting them, shipping them, sending them to Copenhagen, and then presenting them. Here you can see actually the mayor of Copenhagen, the mayor of Toronto, trying them out for the first time.
I will follow. I said, run away, run away, run away. Oh, I felt it. Excellent. This bike is fantastic. It's incredible. It takes no effort. You see my bike? You start pedaling and the motor takes over. And then it will tell you the air quality, temperature. It's amazing to see an idea come to fruition like that.
And I want to share this with you because of the way, just as one project in more detail of how you have people from many different disciplines coming together to make it happen. And that's what I wanted to conclude with. And how really, if you want to look at digital cities, about digital Earth, we really need to have a different approach about how we work together, coming together from many, many different points of view, in government, in academia, in doing research, in order to tackle actually the real problems we have. And we think that this is very similar to what has been happening in other fields. Now, if you look at knowledge in general, this is how we used to think about knowledge, of something where everything could fit in the right spot. It was still the old idea that St. Thomas in the Middle Ages thought about, of having a summa where you could actually put everything in the right position. But we know that's not the case. Actually, this map, it's a map that was on the cover of Science magazine, one of the top scientific magazine, shows 800,000 papers and how they are now connected. They're connected through citation between one paper and another one. And you see something that you could almost call like a dynamic map of knowledge and connection between disciplines, where you see incredible things, where you see like health and brain research connecting to astrophysics and computer science, really where everything is coming together in a way that's much more similar to the map of the internet, if you want. And that's another article from Nature, another scientific magazine, where they actually took the top impact scientific papers from a few decades ago and the ones today. Now, you measure impact using the impact factor, which is a little bit like when you got likes on Facebook, references between one paper and another paper. Now, if you look at the old papers, usually the top papers were the ones by one author from one discipline. It was still the idea you could be like Newton in Cambridge, in England, and an apple will fall, and you get a great idea, publish it, and get a lot of citations. But today, actually, the top highest impact factors are the top papers are the ones from many, many authors from different disciplines. And we believe the same is happening, really, is touching other things, is touching in particular design. This is the old idea of design. It was usually one single person designing and making decisions for millions of people. This is actually Le Corbusier, one of the most celebrated architects of the past century, presenting his plan voisin for the city of Paris. Well, his plan was quite simple. It was demolish everything, just leave the church of Notre Dame as and a few other things as a little reminder of the past, and replace all of this with these beautiful new skyscrapers that you see here. And here you see the hand of Le Corbusier, like the hand of the architect, almost like the hand of God, showing his plan to the people and to Parisians. And people said you couldn't, even if you wanted, you couldn't really work in a collaborative way. There's a saying in design that goes, a camel is a horse designed by a committee. So if you've got a committee, you don't end up with a horse, with a beautiful horse, but with a camel. Well, we know now that that's not the case. That's not the case. We know that we've learned, like on Wikipedia, that people together can do beautiful things. We know that that's happening in design as well. There's actually an issue of Domus, one of the key design magazine, about open source architecture. They came to me and asked me if I would write the editorial for this issue. And I say, sure, I'm happy to do it, but let's do the very editorial, let's do it in a collaborative way. So actually with Nicolas Negroponte, Hans-Ulrich Obrist, and many, many others, we brought it together online, each of us contributing part of it, and it came out as, as a piece that keeps on evolving. If you go and read it up and look it up on Wikipedia now, it kept on evolving since when it was published. And Domus also when you do an editorial, they want to put a picture of you. So what type of picture should we put? So in the end, we come up with the idea, well, we put the picture of all of us combined together, one superimposed with the other. And what we'd like to hope is that actually the picture of tomorrow's engineers and architects and planners will be less like the picture of Le Corbusier presenting his Plan Voisin for Paris, but more like a picture like this, a picture that combines all of us. Thank you.